my dear children, welcome to the mathematics class. Today we are going to discuss integrals. In this chapter, we are going to discuss the sums in the exercise 7.5, page number 322 in the textbook. Okay, my dear children. In the previous class, we have discussed the concepts of this exercise 7.5. I hope you have learned the concepts of exercise 7.5. I hope you understood the concepts of the exercise 7.5. Okay, my children. Now we are going to start the sums in the exercise 7.5. Are you ready to listen the class? Right. Come to the question number 1. First question. Integrate x by x plus 1 into x plus 2. Okay, my children. Throughout this exercise, we are finding the integrals by partial fractions method. Throughout this exercise, we are integrating rational functions by using partial fractions method. Okay, my children. Right. Now, this is the question. We have to integrate this function. If you observe, this is a rational function. Numerator is a polynomial in x and the denominator is also a polynomial in x. Now come to the solution part. Let us assume that capital letter I is equal to integral x by x plus 1 into x plus 2 dx. Okay, my children, understood this step? Right. Now, what is integrand here? X by x plus 1 into x plus 2. Here integrand it is in the form of p of x by q of x, where p of x is equal to x and q of x is equal to x plus 1 into x plus 2. First of all, we have to check whether this rational function is improper fraction or not. If it is a proper rational function, then we proceed. Otherwise, we have to convert this rational function into proper rational function. Okay, my children. Now, how do you identify whether it is a proper rational function or not? On the basis of degrees. Okay, degree of p of x. What is the degree of the numerator? 1. Degree of q of x. Degree of q of x. What is the degree of q of x? Previously I told you, this is a linear factor, this is also a linear factor, linear expression, this is also linear expression in x. So the degree of this denominator can be found by adding the exponents of x. What is the exponent of x here? 1. Here exponent of x is 1. So 1 plus 1, that is 2. Understood this step, my children, how to find the degree of a polynomial which is given in this form. Okay, my children. Right. Then the degree of p of x is here. Degree of p of x is less than degree of first we have to confirm this statement whether the degree of p of x is less than the degree of q of x or not. Yes, 1 is less than 2, isn't it or not, my children? Right. Therefore, the given rational function is a proper rational function. Isn't it or not, my children? It is a proper rational function. Therefore, integrand is a proper rational function. because the degree of p of x is less than the degree of p of x, then it is a proper rational function. First of all, we have to confirm this one. Otherwise, we have to divide the numerator by denominator. We have to convert, we have to transform this improper rational function into proper rational function by using long division. Okay, my children, understood this point? Right. So, we confirmed here the given integrand is a proper rational function. Only for proper rational function we use the integration by partial fractions method. Okay, my children, right. Now let us take the integrand. What is integrand here? X by. So let x by x plus 1 into x plus 2. This is a type 1 problem. In this type 1 problem, the denominator contains only non-repeated linear factors. X plus 1 is a linear factor, x plus 2 is another linear factor. Both are distinct linear factors, isn't it or not, my children? So, non-repeated linear factors. Denominator contains non-repeated linear factors. For every corresponding to non-repeated linear factor, we write a partial fraction like this: a by x plus 1. Let us take this first non-repeated linear factor. Corresponding to this non-repeated linear factor, we write a partial fraction: a by, capital letter A by x plus 1. Understood this term, my children? Right. Plus another non-repeated linear factor is there, that is x plus 2. Corresponding to this non-repeated linear factor, we write a partial fraction, another partial fraction. Understood this second partial fraction, my children? These are partial fractions. We are decomposing, we are splitting this entire rational function into two partial fractions like this. Okay, my children, understood this step? Right. Let us assume that this is equation 1. Okay, my children, listen the steps carefully, my children. Integration by partial fractions method. Okay, my children? Right. Now we have to, now the task is to find the values of a and b. Okay, my children? Right. This implies we write LHS as it is x by x plus 1 into x plus 2. Now come to RHS. Let us simplify RHS. Take LCM for the denominators. If you take the LCM for the denominators, x plus 1 into x plus 2 is the LCM for these two denominators. Understood this LCM, my children? Right. Now let us write the numerator. A into x plus 1, just like a cross multiplication. A into x plus 2 plus b into x plus 1. Understood this numerator, my children? Here this factor gets cancelled. What will be left here? X plus 2. So x plus 2 into numerator. Plus here x plus 2 gets cancelled. Which factor will be left here? X plus 1. So b into x plus 1. Understood this step, my children? Right. Now on the both sides, denominator gets cancelled. X plus 1 into x plus 2. Okay, my children, understood this step? Right. This implies x is equal to, what is left here? X is equal to a into x plus 2 plus b into x plus 1. A into x plus 2 plus b into x plus 1 is left in RHS. Okay, my children, understood this step? Right. Let us assume that this is equation 2. This is equation 2. In this equation 2, we have to substitute x is equal to minus 2. What is the linear factor here? X plus 2. In rough work, take the linear factor. What is the first linear factor here? X plus 1. Okay, my dear children. Take x plus 1 is equal to 0. We have to do this rough work in the rough paper. Okay, my children. To substitute the value of x, we have to find x is equal to minus 1. So take the first linear factor in rough work and write is equal to 0. We have to write this equation. Okay, my children. From this equation, you have to find the value of x. What is the value of x? You got here x is equal to minus 1. So substitute x is equal to minus 1 in the equation 2. Okay, my children. Put x is equal to minus 1 in the equation 2. Then we get in LHS as well as in RHS, we substitute x is equal to minus 1. Okay, my children, in LHS x is there, so I wrote minus 1 is equal to a into minus 1 plus 2. X is there, so we are substituting x is equal to minus 1 plus 2 plus b into minus 1 plus 1. Understood this step, my children? In this equation 2, we substituted x is equal to minus 1. Then we got this step. Okay, my children, understood this step? Right. This implies minus 1 is equal to, let us simplify 2 minus 1. What will you get? 1. 1 into a only. I am calculating this entire part in our mind and I wrote directly this term. The first term is a only. Plus, what will you get here? Minus 1 plus 1. What will you get? 0. 0 into b. 0. Isn't it or not, my children? So, plus 0. I am not writing the second term plus 0. Understood this point, my children? Right. So, minus 1 is equal to a. This implies a is equal to minus 1. A is equal to minus 1. This is the value of a. So, we got the value of a. Now, we have to find the value of b. Understood these steps, my children? To get the value of b, take the second linear factor in rough work. We follow the same procedure. Okay, my children? Understood? Right. So, we got here the value of a. Similarly, we have to find the value of b. Then, what is the second linear factor? X plus 2. Isn't it or not, my children? So, in rough work, write the second linear factor, that is x plus 2. Okay, my children, is equal to 0. We have to write this equation to find the value of x. As we have followed to find the value of a, we follow the same steps here. Okay, my children, this implies x is equal to minus 2. X is equal to minus 2. So, we have to substitute x is equal to minus 2 in the equation 2. Okay, my children, understood this step? Right. So, put x is equal to minus 2 in equation 2. In equation 2, we get, in this equation 2, let us substitute x is equal to minus 2 in this step. This implies, here in LHS x is there, so minus 2 is equal to, what is the first term? A into x plus 2. So, a into minus 2 plus 2, a into minus 2 plus 2 plus b into minus 2 plus 1. Understood this step, my children? In this equation 2, we substituted x is equal to minus 2. Then we got this step. Understood this step, my children? Right. Now let us simplify. Okay, my children? That implies minus 2 is equal to, here a into minus 2 plus 2. What will you get here? 0. A into 0, 0. So I am not writing that term. I am not writing first term, 0. Now come to the second term, b into minus 2 plus 1. What will you get here? Minus 1. So finally, after simplification, what will you get? Minus 1 into b, minus b. Understood this step, my children? Right. This implies minus minus gets cancelled. B is equal to 2. So we found the value of b also. We found here the value of a, that is minus 1. Here we found the value of b, that is b is equal to 2. Now we substitute these two values. By substituting these two values, a is equal to minus 1 and b is equal to 2 in the equation 1. We substitute these two values in the equation 1. What is the equation 1? Substitute a is equal to minus 1 and b is equal to 2 in the equation 1. The equation 1 we get x by x plus 1 into x plus 2, x by x plus 1 into x plus 2 is equal to a by, we wrote a by x plus 1. What is a here? Minus 1 by x plus 1 plus b by x plus 2 in the equation 1. Okay, my children. What is b here? 2. 2 by x plus 2. Okay, my children. By substituting these two values in the equation 1, then we get this step. Okay, my children. Now we integrate on both sides. Integrating on both sides. Integrating on both sides, then what will you get? Integral x by x plus 1 into x plus 2 dx is equal to integral minus 1 by x plus 1 plus 2 by x plus 2 dx. Okay, my children, we are taking the integration on both sides, then we get this step. For this equation we are integrating on both sides. Okay, my children, understood? Right. This implies in LHS we assumed this entire integral as capital letter I. Okay, my children, this implies capital letter I is equal to, come to the RHS part. Integral of two terms are there, so we can find the integral of these two terms separately. Okay, my children, so I am writing directly minus integral of 1 by x plus 1 dx plus 2 into, because 2 is a numerical coefficient, I am writing it before the integral sign, 1 by x plus 2 dx. Understood this step, my children? Here I am finding the integral of these two terms separately. So I wrote this step. Understood this step, my children? Right. This implies this is equal to minus, it is in the form of integral 1 by ax plus b, a linear expression. A linear expression. Then what is the formula? Log mod ax plus b. Log mod into 1 by x means log mod x. Here linear factor is there, so log mod x plus 1 by, what is the coefficient of x here? 1. Understood this step, my children? Understood this first term, right? Plus 2 into it, this is also in the form of integral 1 by ax plus b, a linear factor, linear expression, log mod x plus 2 by coefficient of x is 1. Understood this step, my children? Right. Writing here formula because integral 1 by ax plus b is equal to 1 by a integral 1 by ax plus b. If the linear factor is there, linear expression is there in the denominator, then its formula is 1 by a log mod ax plus b. Okay, my children, by using this integral formula, I wrote these two terms. Understood this step, my children? Right. This is equal to minus log mod, integration part is over. Now we are simplifying the answer. Now it is in the form of m log a. This can be written as log mod x plus 2 whole square. Isn't it, or not, my dear children? Because m log a is equal to log a to the power of m, where m is equal to 2, a is equal to x plus 1. By using this logarithmic property, we wrote the second term as log of x plus 2 whole square. Understood this step, my children? Right. Again, you observe This is log A minus log B. What is the formula? What is the logarithmic property? Log A minus log B. Log of A by B. So log of x plus 2 whole square by mod x plus 1. Because log A minus log B is equal to log of A by B. Log A minus log B is equal to log of A by B by using this logarithmic property, where A means A plus x plus 2 whole square, B means mod x plus 1. Understood this step, my children? Right. So simplification part is also over. This is the last step. So for this last step, what should we do? We have to add constant of integration. Okay, my children? So log mod x plus 2 whole square by x plus 1 mod x plus 1 plus c. Understood this last step, my children? Right. Log of okay, my children? Understood? Right. Come to the question number 3, third question. You try the question number 2 by writing the denominator as x square minus 3 square. Second question, I am giving the hint. Okay, my children? So x square minus 9 is there in the denominator. You write x square minus 3 square. So x square minus 3 square can be factorized as x plus 3 into x minus 3, because it is in the form of a square minus b square. So by using that algebraic identity, denominator can be factorized as x plus 3 into x minus 3. After that follow the steps as we have followed for solving the question number 1. Okay, my children, will you do the question number 2 yourself? Try the question number 2 yourself. If you have any doubt, ask your doubts and get your doubts clarified. Now come to the question number 3. Integrate 3x minus 1 by x minus 1 into x minus 2 into x minus 3. Understood this question, my children? Right. Come to the solution part. Let us assume that capital letter I is equal to integral 3x minus 1 by x minus 1 into x minus 2 into x minus 3 dx. Okay, my children? If you observe the integrand, it is a rational function. It is a rational function. What is the first step? We had to check. First and foremost step is verifying the rational function, whether it is a proper rational function or not. Only this integration by partial fraction method is applicable only for proper rational functions. Okay, my children, keep this point in your mind. Okay, my children. Now what is the integrand here? Integrand p of x by q of x. It is in the form of p of x by q of x, where p of x is 3x minus 1. It is a polynomial of degree 1. It is a linear polynomial. Whereas q of x, x minus 1 into x minus 2 into x minus 3. This is also a polynomial in x. Okay, my children. First of all, we have to check whether this integrand is a proper rational function or not. How can you decide this rational function is a proper rational function or not? Based on the degrees of numerator and denominator. So what is the degree of p of x? What is the degree of numerator? What is the highest power of x? Highest exponent of x? 1. So the degree of this numerator is 1. Understood this step, my children? Right. Now come to the degree of denominator. Here 3 factors are there. In the denominator, 3 linear factors. So to find the degree of these linear factors, you add the exponents of each factor of x. Exponent of x should be added. What is exponent of x here? 1. Here what is exponent of x? 1. Here what is exponent of x? So 1 plus 1 plus 1. Okay, my children, not coefficient of x, exponent of x. Okay, my children, don't be confused. You have to add the exponents of x. 1 plus 1 plus 1. What is the result? 3. So it is a polynomial of degree 3. Numerator is a polynomial of degree 1. Denominator is a polynomial of degree 3. Understood this point, my children? Right. So here degree of p of x. Degree of p of x. One is less than 3 or not? Yes. So degree of p of x is less than degree of after confirmation this statement only we proceed for the next steps. Okay, my children? Right. So it is a proper rational function. Therefore, integrand is a proper rational function. After confirmation of this statement only we follow the steps further. Okay, my children? Right. Now come to the integrand. Let us take the integrand. Let 3x minus 1 by 3x minus 1 by x minus 1 into x minus 2 into x minus 3. Now we have to split, we have to write the partial fractions to this rational function. Okay, my children. Now come to the denominator. We have to observe the denominator. In the denominator, this is a non-repeated linear factor. This is also a non-repeated linear factor. This is also a non-repeated linear factor. So for every non-repeated linear factor corresponding to for every non-repeated linear factor we have to write one partial fraction. So this is x minus 1 is a non-repeated linear factor. So corresponding to this non-repeated linear factor we have to write one partial fraction. So capital letter A by we write this non-repeated linear factor. Understood this partial fraction, my children? Right. Plus we are going to write second partial fraction corresponding to this non-repeated linear factor, this second non-repeated linear factor. So corresponding to this non-repeated linear factor we have to write a partial fraction like this, b by x minus 2. Understood this step, my children? Understood this second term? Right. Now come to the third. X minus 3 is also a non-repeated linear factor. So corresponding to this non-repeated linear factor we have to write one partial fraction like this, capital letter C by x minus 3. For every corresponding to every non-repeated linear factor we wrote partial fractions. Means we are splitting, we are decomposing this rational function into 3 partial fractions. Okay, my children, understood this step? Right. Let us assume that this is equation 1. Let us assume that this is equation 1. In this equation, capital letter A, capital letter B and capital letter C are unknown quantities. You have to find A, B, C values. As we followed for the question number 1 to find the values of A and B. Here also we follow the same steps. Okay, my children? Right. So, this implies we write LHS as it is 3x minus 1 by x minus 1 into x minus 2 into x minus 3 is equal to, what we have done there, we have to find the LCM of the denominators. What is the LCM of the denominators? X minus 1 into x minus 2 into x minus 3. Okay, my children, understood this LCM of these 3 denominators? X minus 1 into x minus 2 into x minus 3. Now we write numerator. So first we write capital letter A into, we write this number as it is. Here x minus 1 gets cancelled. What are the factors left here? X minus 2 into x minus 3. We write that factors. X minus 2 into x minus 3. Understood? This is the first term in the numerator. Understood? This is the first term, my children. Right. Plus. Keep plus sign. What is the numerator? B. We write that numerator as it is. Come to the denominator. X minus 2 is there. Here x minus 2 gets cancelled. Then what are the factors left here? X minus 1 into x minus 2. So x minus 1 into x minus 2. This is the second term in the numerator. Understood? This is second term, my children. Right. Similarly, we write the third term plus. We write c into here x minus 3 is there. So x minus 3 gets cancelled. What are the factors left here? X minus 1 into x minus 2. We write this one. X minus 1 into x minus 2. This is the third term in the numerator. Understood? These three terms in the numerator, my dear children. Right. After writing the numerator, we strike out the denominators here. See here, x minus 1 into x minus 2 into x minus 3. Same. So we can strike out. Then what will you get in the LHS? 3x minus 1. In the numerator, what is left here? 3x minus 1 only is equal to, we write this part, RHS, a into x minus 2 into x minus 3 plus b into x minus 1 into x minus 1 into x minus 2 plus c into x minus 1 into x minus 2, x minus 1 into x minus 2. Let us consider this is equation 2. Do you remember these steps, my dear children? In the first question, we followed the same steps here also. So, we considered this equation as 2. Now, we have to find the values of A, B and C. Then, what are the steps we followed here? In the first question, what is the first factor here? X minus 1. X minus 1 is the first factor. So, in rough work, I told you, take the first linear factor. Here first linear factor is x minus 1. So in rough work, take that first linear factor, that is x minus 1. In the integrand, first linear factor is x minus 1. I wrote here x minus 1 is equal to 0. Put is equal to 0. Then we get an equation. X minus 1 is equal to 0. Now we have to solve the equation for x. This implies what is the value of x? X is equal to 1. By transposing minus 1 to RHS, it becomes plus 1. So 0 plus 1, 1 only. Understood this step, my children? So we got x value is 1. So we have to substitute x is equal to 1 in this equation 2. Put x is equal to 1 in the equation 2. In the equation 2, we get, in this equation, we are substituting x is equal to 1. Okay, my children, understood? This implies 3 into 1 minus 1 is equal to a into 1 minus 2 into 1 minus 3. Okay, my children, b into 1 minus 1 into 1 minus 2 plus c into 1 minus 1 into 1 minus 2. Understood this step, my children? In this equation 2, I substituted x is equal to 1. Then we got this step. Okay, my children, understood? Right. This implies 3 minus 1. 3 ones are 3 minus 1. Understood this step, my children? Right. That is equal to a into, here what will you get? Minus 1. In this bracket, 1 minus 2. In this bracket, 1 minus 2, you get minus 2. 1 minus 3, what will you get? Minus 2. Understood this first term, my children? Come to the second term, 1 minus 1, what will you get? 0. 0 into anything, what will you get? 0. So I am not writing the second term, plus 0. I am not writing right second term. I am not writing the second term. Plus, now come to the third term. Here also 1 minus 1, 0. So here third term also we get 0. So I am not writing second term as well as third term. Understood this step, my children? We get only this first term. Okay, my children? So from this equation we can find a value. Okay, my children? Right. So let us simplify. Let us find the value of a here. This implies what will you get here? In LHS 3 minus 1. What will you get to? 2 is equal to a into minus 1 into minus 2. What will you get to? 2. 2 into a. 2a. Understood this step, my children? Right. This implies here 2 gets cancelled. Then what will you get? A is equal to 1. Okay, my children? Understood? Right. Again, I will write the equation 2 here. Then I find B value as well as C value. Okay, my dear children? Right. Here, my dear children, I wrote again equation 2 here. I wrote the equation 2 again. So, we got the value of A. Now, we have to find value of B. To find the value of B, what is the second factor in the integrand, in the denominator? X minus 2. So, in rough work, put x minus 2. What is the second linear factor in the denominator? In the integrand, x minus 2. So, we write x minus 2 is equal to 0. From this equation, what will you get? X is equal to 2. Like this, we have to find the value of x to substitute in the equation 2. Okay, my children. So, we got here x is equal to 2. So, substitute. Put x is equal to 2. Put x is equal to 2 in the equation 2. What you will get here? This implies 3 into 2 minus 1 is equal to a into 2 minus 2 into 2 minus 3 plus b into 2 minus 1 into 2 minus 3 plus c into 2 minus 1 into 2 minus 2. In this equation 2, this is equation 2. I wrote again. In this equation 2, I am substituting, put x is equal to 2. Understood? How we got the value of x? We have taken the second linear factor in the denominator and we wrote this equation is equal to 0 and we solved this equation for value of x. We got x is equal to 2. Whatever the value of x we got here, we have to substitute that value of x in this equation 2. Then we got this step. Understood this step, my children? Right. Now let us simplify LHS as well as RHS. What will we get? 3 2s are 6 minus 1 is equal to, here 2 minus 2 we get 0. So I am not writing the first term. Understood this first term, my children? We are getting 0. So I am not writing first term. Come to the second term. B into 2 minus 1. B into 2 minus 1. What will you get? 1. 2 minus 3. What will you get? Minus 1. Okay, my children, I wrote only second term because we are getting first term is 0. That is why I am not writing the first term. So I wrote the second term directly. Now come to the third term. In the third term also 2 minus 2 is 0. So 0 into any number we get 0. So here third term also 0. So I am not writing third term also. Finally we get only one term. First term is 0 and last term is also 0. Understood this step, my children? That is why we get this step. Okay, my children? Right. This implies 6 minus 1. What will you get? 5 is equal to b into minus 1. 1 into minus 1. What will you get? Minus 1. So minus 1 into b minus b. Understood this step, my children? Right. This implies b is equal to minus 5. B is equal to minus 5. We got b value. After that, we have to find c also. We got a value. A is equal to 1. B value. Similarly, we have to find c value. We follow the same steps. What is the step to be followed here? We have to do the rough work. In this rough work, take the third linear factor in the denominator. What is the third linear factor in the denominator? X minus 3. So is equal to 0. Write this equation and solve it. Then what will you get? X is equal to 3. Understood this rough part, my children? Rough work. Understood this one? So put x is equal to 3. Put x is equal to 3 in the equation 2. Okay, my children? Put x is equal to 3 in the equation 2, then we get, in this equation 2, we substitute x is equal to 3. Then what will you get? This implies 3 into 3 minus 1 is equal to a into 3 minus 2 into 3 minus 3 plus b into 3 minus 1 into 3 minus 3 plus c into 3 minus 1 into 3 minus 2. Understood this step, my children? In this step, in the equation 2, this is equation 2. In this equation 2, I substituted x is equal to 2. Then we got this step. Understood this step, my children? Right. Now let us simplify this step. This implies what will you get? 3 3s are 9 minus 1. Okay, my children, understood RHS, LHS. Now come to RHS. If you observe this first term, 3 minus 3, what will you get? 0. So 0 into any number, we get 0 only. So what is the value of first term? 0. So I am not writing the first term 0. Okay, my children. Now come to the second term. Here also 3 minus 3. What is the value of 3 minus 3? 0. So 0 into any number, we get to 0. That is why I am not writing the second term also. Now come to the third term. C into, what will you get? 3 minus 1? 2. Into 3 minus 2, what will you get to? 1. Just I wrote only third term because we are getting first term value is 0 and second term value also 0. So I am not writing these two terms. Directly I am writing the third term. Then we got this step. Understood this step, my children? Right. This implies, what will you get? 9 minus 1, 8 is equal to, in RHS, C into 2 into 1. What will you get? 2C. Understood this step, my children? Right. This implies 2C is equal to 8. This implies C is equal to 8 by 2. By transposing 2 to RHS, it becomes by 2. So 8 by 2. 2 1 times, 2 4 times. This implies C is equal to 4. So we got here A is equal to 1, B is equal to minus 5 and C is equal to 4. Understood these three values, my children? Now we substitute A, B and C values in the equation 1. Okay, my children? Understood? Right. Then we follow the same steps, integrating on both sides. Okay, my children? Right. Now let us substitute A is equal to 1, B is equal to minus 5 and C is equal to 4 in the equation 1. Then we get 3x minus 1 by x minus 1 into x minus 2 into x minus 3 is equal to A by, that means A 1 by x minus 1 plus B by, B means minus 5. So minus 5 by x minus 2 plus C by plus 4 by x minus 3. Understood this step, my dear children? We substituted A, B and C values in the equation 1. Then we get this step. Then we follow the same steps as we followed for the first question from here onwards. Integrating on both sides. Integrating here, we have splitted, we have decomposed this rational function into 3 partial fractions. So for this one, we have done all this part. Okay, my children? Right. So integrating on both sides. Integrating on both sides. This implies integral 3x minus 1 by x minus 1 into x minus 2 into x minus 3 dx is equal to, here I am writing the integration of the each term separately directly. Okay, my children? Integral 1 by x minus 1 dx minus 5 into, here numerical coefficient is 5, so I am writing the before the integral sign. So minus 5 into integral 1 by x minus 2 dx plus 4 into, here 4 is a numerical coefficient, we can write it before the integral sign. So 4 into integral 1 by x minus 3 dx. Here I wrote the steps directly, direct step. I wrote here direct step. Understood this step, my children? For each and every term we are finding integral. Okay, my children? Understood this step? Right. Now it is the first term. It is in the form of integral 1 by ax plus b. Previously we applied that formula for the first question. What is the formula? Log mod x minus 1. Log mod x minus 1 minus 5 into, here also by 1. X quotient is 1. 5 into, this is also log mod x minus 2 whole divided by 1. X quotient is 1. Plus 4 log mod x minus 3 whole divided by 1. Because integral 1 by ax plus b dx is equal to 1 by a log mod ax plus b. The denominator we have to write the coefficient of x. What is the coefficient of x here? A. So 1 by a. I wrote as a denominator. So 1, 1, 1. Understood this step, my children? Right. Then we can use the logarithmic properties, or we can leave that by this step also. Okay, my children? Right. So log mod x minus 1, log mod x minus 1 minus 5 log mod x minus 2 plus 4 log mod x minus 3. Okay, my children, plus c. We can use here logarithmic properties and we can simplify as a single term. Otherwise, we can leave this step by this step. Okay, my children, this is the last step. We can consider this is the last step. So, for this last step, we are adding the constant of integration. Understood, my children? Right. Similarly, you try the next question, that is question number 4. Okay, my children? Question number 5 also. Try the question number 5 also. But in the denominator, question number 5, in the denominator, a quadratic polynomial is given. Please observe the denominator in the question number 5, my dear children. It is a quadratic polynomial. First factorize the quadratic polynomial. You get 2 factors. Isn't it or not, my dear children? X plus 1 into x plus 2 are the factors of the denominator in the question number 5. So you got 2 linear factors in the denominator. So accordingly, you write the partial fractions for this rational function. Question number 5. Okay, my dear children. Right. Do the question number 5 and question number 2 yourself, and question number 4 also same like this. Okay, my dear children. Right.